students, today we are going to solve the linear equations by the simplex method. Now this is the maximize conditions. Now this is the constraints, so that first we will just solve. We will just write the given part. Okay. Now okay, let's here for the constraints subject objective for the objective equations. Here we'll add the slack variables that call the S1. Okay, slack S1 equal to 6. This becomes the equation first. And second equation is x1 plus 3x2. Now here also we'll add another slack variables, that is s2, which equals to 9. Equations second. Now in this way, here are the restrictions: x1, x2, s1 and s2, which is greater than equal to 0. This is the restrictions. Now for the maximize conditions for the objective functions, we will just replace the, we will just forward the conditions. For example, z, this can be many into minus 3x1 minus x2. Now here slack variables are also added, so 0 into s1 plus 0 into s2, okay, is equals to 0. Okay, now we have just reformed the objective functions. Now we will form the initial table of the simplex forms. Okay, initial table of simplex form. Simplex forms. Now this is the revised simplex tables, so that for in upper part we'll just write the z coefficient of the z, the basic variables also, basic variables. Okay, here what we will do is that first we will just write the coefficients of the z, and then similarly first we will write the coefficient of the z also here. Now we can just, okay, for the basic variable here is x1, x2, s1, s2. Actually this x1 and s2 are the non-basic variables, and s1 and s2 are the basic variables. For the z here, minus 3 coefficient, we'll write the coefficient minus 1, 0, 0, and then for the right hand side the ratio, okay, you can write as the right hand side there is 0, so we'll write here 0, and for ratio also you write the ratio, later it will work. Now for the s1, we'll write the coefficient of this subject x1, 2, 1, 1, 0, the right hand side, that is 6. For the s2, now there will write 1, 3, 1, sorry, this is equal to 0, and 1 is equal to 9. Now look at here, this is the initial simplex table, okay, and then it is revised simplex forms. So first here we will see the most negative entry. You can look here, this is the most negative of the objective function, so this will be your key column. Okay, this will be your key column, so that here therefore minus 3 is most negative entry, so x1 is key column. Okay, now through here we can just define that key column means that this will be the key columns of this for this tables. Okay, now for the ratio we will divide RHS by this x1. So whenever 0 is divided by minus 3, value 0, 6 is divided by 2, then result will be 3, 9 is divided by 1, then that is 9. So here we will see the least part, this 3 is the least one, so that this will be your key row. How to define the key row? So to define the key row, we will just see the list in the ratio. So here both consist, 2 is the key element, so we can write here therefore 2 is key element. Now here what we can do is that we have got the key row and the key columns with the key element. From here we'll first make this divide by the, we'll make the key element 1, and then we'll just, after that we'll just, for the key row we'll make the 0, so that as we will apply the row equivalent method. So we'll apply here applying R2 is equals to R2 divided by 2. Okay, after that what we will get? Okay, base 6, this is base 6, x1, x2, s1, s2. Here it is the RHS and the ratio. This is the tables. Okay, now here is the s1, here is the s2. Now when we divide this okay, z s1 s2, okay, z as it is, I copy from before table this. Okay, now we will divide these terms. 1, this is 1 by 2, this is also 1 by 2, 0, this is 3. Now this will be 3, 1, 3, 0, 1, 9. Okay, this is the terms. Now here what we got the change is that in the RHS you can just look at the RHS 1, 3, 0, 1, 9. In the RHS there is certain change in the S1. So now what happens? This will be your X2. This will be your X2, because X1, because what happens? X1 is the, this S1 is the living variable, and this is this S1 is the living variable, and X1 is the entering variables. Now we will just operate. Now we will make this as R1 0 and R2 also 0. So first column, okay, applying R1. Now we will make this column, this first columns, this minus 3 0. To make the column 0, we will take help of the R2. Okay, this is known as the R0. This is known as the R1. This is known as the R2. Okay. After that, R0 is equals to R0 plus 3 times of R0, R1. Similarly, R2 is equals to R2 minus R1. If we apply this, we will get this terms. Okay. Basic variable x1, x2, s1, s2, RHS and ratio. Let's see. After applying there, what we will get here? S1, S1. Now look at here. Here we will get the 0, 1. This is also 0. Now what we will get here? Okay, minus 1 minus 1 times 2 by 3 means the minus 1 plus 3 by 2. Okay, this result will be, you can take it the result 1 by 2. Okay, and the S1, that will be the 3 by 2. Similarly, this will be the 0. Now turn up the right hand side. Here will be 3 times 3 is 9. Okay. Now this will be the as it is forms 1 by 2, 1 by 2, 0 and 3. And then what for the second R2 will apply the 0, 3 minus 1 by 2, 3 minus 1 by 2 is 5 by 2. And then that is the 1 by 2. This is minus 1. 9 minus 3 is equals to 6. Now look at that. In this Z row, so here is no negative entry. Here is no negative entry means that Z, therefore this will be your solutions. Okay, Z is equals to 9, x1 is equals to 3 and x2 is equals to 6. This will be your solutions. Okay, finally we have got maximum Z, that is the 9. Okay, at what? X1 is equals to 3 and x2 is equals to 6. Okay, thank you.